Hi everybody, I'm John Sarter with my company, my private company is Off the Grid Design. I'm actually thinking of changing to Of the Grid Design, or just a little asterisk around, because in my opinion, it's great to be able to island, but there's a lot of value to staying interconnected with the grid and being a partner to the grid or the local microgrid, but having that ability to island when this stuff hits the fan. So I'm also the program manager for the Clean Coalition in the North Bay Community Resilience Initiative, and we're working up there to try and help people build and rebuild with resilience in what they do, and starting out with critical facility microgrids, helping municipalities develop RFPs for actual microgrids in their communities, hospitals, fire stations, police stations, they build critical facilities, starting with them with the ability to interconnect it to community microgrids later. I'm going to start out talking about a project I did here in San Francisco. Except I think I turned it off. Should have taken a tutorial there. There we go.
Plug into a microgrid.
Yeah, perfect. Okay, so this project is a 4-unit, 6-story condominium building here in the Mission called Solux Alpha. And this is a 100% renewable energy powered net positive energy nanogrid structure. And the reason I call it a nanogrid structure instead of a microgrid is that it is actually 5 separate energy systems that are separate from each other. We could not interconnect them because of the utility rules regarding interconnection of separate systems that are privately owned. So that's part of the policy work that needs to be able to happen in order to make that to be a possibility moving forward. A net positive energy nanogrid structure generates more than all of the required energy for the structure with 100% site-based renewable energy systems. It stores that generated energy in on-site energy storage systems, manages the energy with systems within the systems with site-based and cloud-based management and control systems. And the reason I emphasize site-based and cloud-based is that if the grid goes down and your cell towers go out, you need an on-site management system that can keep everything running, and hopefully you can actually control it from the site itself. So it also will interconnect for energy export or import with the local grid or microgrid, and or operate in an islanded mode in grid disruption events such as PSPS events. And then you can also import and export that excess energy to the grid for grid balancing services, ancillary services, and monetize that. And there actually are now aggregators that can help you, even as a single owner of an energy storage system, aggregate your asset into the larger pool and actually participate in the KISO market. So it's a new kind of a source of revenue that's just fairly recently come into being. Then you can export your excess energy for revenue as well if you can sell it to a CCA such as SF Clean Power or MCE, and Sonoma Clean Power actually will pay you the current rate of time of use while you're exporting plus a penny. What you export up to, I think, a maximum of 5,000 per year, is that correct? Yeah. So it's a pretty good incentive for actually generating more than you're using, which hasn't always been the case. Then you can also export energy for off-site EV charging or for community energy for Clean Power, SF, or other CCAs, etc. One of the things we tried to do in this building was really showcase the energy asset as sort of an art form. So we like to show this energy as art, and it's a bifacial array. You can see there, the sun can shine in around the edge of the solar cells, which face upward and downward. The cells that face downward actually catch reflected light from the deck and from this ambient light from the community, and those panels will actually generate up to 25% more than the standard panel by doing that. They're a little more expensive, but when you factor in the excess generation you get, it's really about the same cost. So it worked out pretty well. This building has 96 panels that are 380 watt panels each, plus up to a 30% boost, so it turns a 380 watt panel into a panel that's producing almost 500 watts. And then it also allows a mix of direct and filtered sunlight on the roof deck, which is an outdoor space, an outdoor kitchen up there and a dining area for the residents. It's also designed, it's all interconnected, designed for integrated rainwater catchment, and also integrated RGB LED lighting between the rows that would make it glow at night. Any color you want, pull out your phone, pick your color, waves of color. Unfortunately, that got cut out of the budget, so I'll have to wait till the next project. I'm looking forward to doing that the next time. By the way, if anybody has a question, just put your hand up. I'd rather talk with you than at you, so if anything comes up, just feel free. So Solux Alpha is was the USA's first multi-unit passive house certified nanogrid, and it's a carbon neutral living and transportation system because of the net positive energy that it generates. So the question is, how did we get to net positive in such a tall building with a small footprint? We started with passive solar siting and design, and that's going to vary by climate, so you're basically shading in the summertime when you want to keep it cool and letting the sun in the winter. And then we used passive house methodology and certification, and passive house basically makes a very airtight building with air circulation and filtration, continual ventilation basically. You pay a lot of attention to thermal bridging so that the solid elements of the building aren't transferring heat and cold through the walls. You insulate it a little extra, and then very good airtight windows and doors. And in San Francisco, it's a pretty easy climate to do that with. We didn't end up having to use triple glazed windows or anything crazy like that. No exterior insulation, just the double dense glass on the outside of the wall and the double sheetrock on the inside was enough to give us the thermal break that we needed to make that pass these certification standards. So that was what we needed anyway for a 2-hour wall. Really, essentially, the only extra cost was air sealing and better quality windows and doors. Go ahead.
Did you have any code hurdles you had to get over in order to do business?
Yes, so the solar array goes to full property line extents, which is not typical. It's the first building in the city actually to do that. So we had to have a special meeting with fire and building, facilitated by Department of Environment. Actually, they really helped us out a lot on this project. So that was one thing, and also to have no space between the rows, which was one thing the fire marshal wanted initially because of ventilation requirements. But since it's raised up on the roof and there's plenty of air circulation, there's plenty of circulation for firefighters, we were able to supersede that code. As far as the rest of the code, we actually certified to the Green Building Code by using Passive House and Department of Energy's Zero Net Energy Ready Home program as an alternate path of compliance. So we didn't do LEED, we didn't do Green Point rated, anything else. This sort of superseded that essentially. But other than that, other than some difficult interconnection issues that Chris mentioned, not really any code issues. Go ahead.
This was new build.
Yeah, new build.
What was your total cost relative to a traditional building?
Under 5% cost per unit. Yeah, I mean, it's so expensive to build in San Francisco right now that 5% is a lot, you know? So it was well under 5%. And we feel we got maybe 10 to 15% of premium on the sales end, so it was well worth it. Part of this was to set an example for other developers to kind of show that you can really step it up and recoup your costs and incentives. I want to go on a little bit before I get a few more questions. So we started out by defining and optimizing a projected energy budget. Kind of just look at everything that you're putting into it and what that energy budget is going to be, and then try to refine it and minimize it with different systems and synergies of systems. We use 100% LED lighting with occupancy sensors where possible. Another way to do it that we didn't in this building would be to use more DC systems and keep it all DC coupled, as Chris said. Every time you invert energy from AC to DC and back again, you get a 3 to 5% loss, so it adds up. We use ultrasonic vacancy sensors actually in this building in the receptacles to reduce vampire loads as well. So when you leave a room, the outlets go off. Not everywhere, because sometimes you really need that outlet to stay powered, but to a great extent. And then we picked the highest efficiency appliances that we could find. I'm currently looking for really good quality DC appliances to create DC hybrid buildings. or maybe even full DC buildings. And then again, I said, create synergies of systems. One idea that we had that we were looking at using was, we have a refrigerator that backs right up to the water heater, and you could actually create a high and low vent here between the two and allow the cool air from the heat pump water heater to come down and help cool the fridge, and the hot air from the fridge to convect up and actually help heat the water. So we ended up, yeah, it's just, it's just, you have to just think about how can you make things work together and use the waste from one thing to help the other.
Excuse me, John.
Yeah.
So, is the heat pump water heater, does that flow to radiators for your heat, or do you use like an air source heat pump?
So we ended up not using this system. We ended up with a sand and CO2 heat pump.
Okay.
And with sand and systems, the compressor goes outdoors.
Yep.
So any cold air that it creates is just ejected into the outdoors, so we're actually helping cool the planet. Yeah, and you also don't get any noise that creates, inside your building. It's a great unit. They're kind of expensive, but they're really nice. What was I-
Sorry, so is that the heating for the building is from the sanding?
No, actually the heating, we use mini split heat pumps.
Got it.
So they provide heating and air conditioning. But, when you do passive house, your energy required for heating and cooling is really minimized. So you reduce your heating system costs, which helps offset the cost for the HRV, the heat recovery ventilation system, or ERV. And then, we're trying to look at, like I said, trying to recapture waste heat energy from air and water. And then one thing we didn't do, we looked at doing in this project, but want to do in future ones, is gamify the system so that people can kind of compete and, for the low energy user, the biggest loser, kind of thing. So Solux Alpha ended up being a true zero carbon living and transportation system. It's all electric, it's completely fossil fuel free. It was the first multi-unit FIAS Plus Source Zero certified building in California. And it has about 47 kilowatt full roof coverage, sun-prime bifacial trellis, about 10 kilowatts per unit, and 7 kilowatts for the common areas. And even though it looks like one big array, it's actually separated out into that 5 separate systems. Originally, we planned it to be one big battery for the building, and everybody shared energy. But that, as I said, was against the interconnection laws, so we had to separate it out, re-engineer it. We did a lot of re-engineering on this building. But I learned a lot. It was great. I would do it again, and I will. It has fully integrated EV charging infrastructure and management, so you can peak charge off-peak, and then potentially use your vehicle even for ancillary grid services to create your and generate revenue. It's B2B and B2G enabled. We wired for that, but the technology was not available at that time, so it's ready for that technology to come into play. I'll talk about that a little bit more in a minute. We use 2 different energy storage systems, the Blue Planet Energy Blue Ions. We have 2 towers. Photo up there, yeah, we have 2 towers over here on the left. Did they get cut out? Sorry, I've got another photo. And then we have also, for each unit, there are 3 Tesla power walls. So we have 186 kilowatt hours total for the building, which is pretty substantial. 3 of those power walls is enough to run each unit for about 2 days or more, if all the power was out, and they're constantly being recharged by the solar, so it rarely actually needs to even pull from the grid at all. So it's a very grid-like building, essentially, sort of grid optimum. The energy management systems are proprietary to each of those systems, and they monitor and manage the variable renewable energy storage assets. We have them set to maximize self-consumption and the variable pair zone. But you can adjust that to kind of customize. And you want to preset what your reserve amount is. So we have these set to 20% reserve all the time. So if the battery is drained down and the grid goes out, you still have 20% capacity in your battery to get through the night or the day cycle. Why energy storage? Well, resilience, of course, and decarbonization and electrification will also create a vulnerability unless you add distributed energy resources at the building and community level. It's really important. As we electrify and decarbonize, I really emphasize that you have to add these distributed energy resources, otherwise we will create vulnerabilities, because you're eliminating a redundant source of energy. You eliminate fossil fuels, right? So, obviously, you have uninterruptible, safe, secure, and zero carbon energy. You'll have an energy and a fuel source during grid outages. You can save money by charging off peak and using at peak times of use. And you can also now, as I said, create revenue from ancillary services to the grid. Lithium-ion batteries, the actual chemistry of the battery really does matter, as Chris was saying. We have the power walls and the blue ion, they both have a different chemistry. The Tesla and LG Chem and some others are lithium cobalt. It's less expensive, but it has a lower cycle life. Also, it's more prone to thermal runaway, as Chris said. So you want to be careful where you place them. They're still indoor rated and UL listed, but the fire marshal here in San Francisco made us put these in a 3-hour fire rated garage and then inside a 1-hour fire rated enclosure besides on top of that. There's actually nowhere in the code that says you have to do that, and I pointed that out to him and he said, the first article of the code says that whatever I say goes. So, how do you argue with that, right? I checked it out, he was right. I'm a big fan of smaller distributed systems even within a building because you create redundancies and fewer single points of failure. And one of the lessons we learned on this actually, as compared to the larger system and the single big battery bank and one big inverter we were going to use, this ended up being less expensive because the smaller components are way less expensive than the larger components are as a whole. The ATS switch we were looking at for the single battery bank was $50,000. And the ATS for the Tesla Powerwalls is in this little box over here. They call it their backup gateway. Those were $700 each. So huge difference, yeah. So it really makes a lot of sense in my mind to just really break it down to smaller components, more easily replaceable, fewer single points of failure.
I assume since this was a new build, the solar and storage interconnection is on the load side of the switchgear?
Yes, on the owner side, yeah.
Owner side.
Yeah.
Maybe not that, but have you had experience in retrofitting systems that had existing solar that were on the blind side and have converted those to microgrids? What has been the cost structure and challenges of that?
I haven't had a lot of
Can you
experience.
repeat the question?
Pardon?
Can you repeat the question?
Oh, yeah, sorry. The question was, have I had experience with retrofitting systems that have solar but not storage and bringing storage in? I haven't
Solar is on the line side of the switchgear.
on the line side.
A lot of the California systems are installed that way.
Oh, really? So that's why they shut down, right?
So the 120%.
Yeah, I haven't had experience with that, so I don't know.
Does anyone
Most of
know
what
if
I do is
that's-
new build, so.
Does anyone know if that's required or just standard practice?
I think it's more standard practice. I don't see any reason why you couldn't put the solar on the load side.
Maybe for sizing reasons, and if you want to optimally size for maximum load reduction, generally you either have to upgrade your switchgear or you go on the line side to avoid the 120%. So
But it's not
converting
banned.
What's that?
It's not banned though.
It's not bad, but to convert that to microgrid, then you're kind of stuck with being like, you have to like redo a bunch of stuff.
Elliot, can you speak up? Can't hear you.
Oh, I'm sorry. But it's a side topic for later. I got kind of carried away seeing that.
That's okay, yeah, definitely. Yeah, we went through some different iterations of engineering, as I said, in the process. But it was all designed to be on the load side from inception. One thing you want to make sure is your battery chemistry is indoor rated, UL listed. It's a level of safety that you want to have no matter what system you're choosing. And then for what I do for reselling of structures, I think the user interface for the customer is really important. You want to have something that's elegant, easy to use, fun to use, sort of intuitive. The Tesla system worked out really nicely, and I'm going to go into some of the data from that in a minute. And it's really important that your customer is happy with the product and you don't have a million callbacks. So, as I said before, we certified through FIAS, Passive House Institute US, and the Department of Energy Zero Energy Ready Home program as our alternate path of compliance. DOE ZNER program includes EPA WaterSense and WaterSense and Indoor Air Plus. So those are important. We ended up winning the 2018 U.S. Department of Energy Housing Innovation Award for multifamily and the 2018 FIAS Best Overall Project. So that was fun to get that after all that work.
Hey, John.
Yeah.
On those, did you install any sort of continuous air quality monitoring in-house? And also, did you look at gray water or any sort of water recycling?
You know, we considered gray water, and our original MEP engineer said don't even go there because it's so complex in San Francisco.
Mm-hmm.
So we sort of abandoned that. And as far as the indoor air monitoring, we didn't actually put one in, but for a period of time I put a FUBOT in. If you're familiar with that?
Yeah.
That's a device you can just plug in, and it's an app you get. During the fires that we had in 2017, I think it was, when the air quality was toxic in San Francisco, the indoor air quality of these units was pristine. And that's because of the air filtration in a very airtight building. And the filters inside the ERVs were black after that event, so it's important to change the filter. But you know, that filter is black instead of your lungs, right? So I like to tell people that this building can actually help you live longer.
Yeah, quick question, John. You said you used ERVs instead of HRVs?
Yeah, we did. We found a really good unit that was comparable in cost and had a really high quality core, and it was an ERV also, so we just did it. I mean, in this climate, you don't really need, an ERV is basically the difference is that it will help you control your humidity in your house as well as do the filtration. So yeah, that's why we use ERVs, just it's a good product for the money. So this is some of the data, current data from Unit 2. They gave me access to their app so I could show it off. So the first screen of the app shows what's happening with your unit. It shows that you have solar and you have storage. They've updated this now. Now it says ×3 on here because there's 3 per unit. And then you can hit these different buttons to see what the power flow is going. This gives you your performance of what's happened today, 98% self-powered. You can check your backup history, and that's how many times it's actually islanded from the grid. And this does actually, it islands even if there's an anomaly on the grid. If there's a spike of energy, it will automatically island. So it's sort of a surge protector at the same time, which is really kind of nice to have. And then this down here is how you can customize your settings, your percentage settings. You can change it from self-consumption to time of use if you want to monetize it more. So this is the second screen you come to, and this shows you the actual power flow of what's happening. This is the solar, and if the solar wasn't producing right now, it was either cloudy or it was night, the solar will come down here, and there's a little blip that brings it down, shows there's powering your home, or powering your home and charging your battery, and then when the battery's full, the arrow goes over here and shows that you're exporting to the grid.
Is this all designed by Tesla?
Yeah, it was, yeah. And I think, you know, like I said, the user interface, the people that bought these units, they like to look at it and play with it. You know, you don't want them to mess with it too much, but it's good to be able to see what's happening. You know? So this is a typical sunny day over here, and you can see this was this is the energy being used by the unit, or here, this blue line is the energy being used. The orange is the solar. This is the battery actually charging from the solar, and then this is the battery discharging back to the house. Oh, I'm sorry, that's once the battery's full, that is exporting to the grid. And there's, in this particular day, the home used 18.9 kilowatt hours, there's 22.2 kilowatt hours used, 11.1 came from the Powerwall, that was at night, and 0.1 from the grid, that's just an anomaly, and then 2 kilowatt hours went to the grid. This was November 23rd, not a particularly sunny time of the year. So even during the winter months, these are staying quite net positive. They've been performing really well. Here's a typical rainy day profile, and you can see there wasn't really any solar. And on this particular day, there was some power drawn in from the grid. So this is kind of why it's a good thing to stay connected to the grid, because you can use that power, and that way you don't have to really oversize and supersize your energy storage system. Have that power when you really need it during long duration, or a backup generator, something like that. So if you can stay connected to the grid, I think it really makes sense to do so. This is the current data from November. This is a weekly chart from November 25th to December 1st. The home used 132, generated 81.6. This came from the Powerwall at night, and and they drew 44.9 from the grid, and a very small amount went to the grid on that week, so it was kind of a rainy week. This is a monthly graph that they give you that shows it by day, and then for the month you can see actually, I believe they were a little net positive here. Yep, so this is November. The home used 575 and then generated 613. Then this is the yearly screen that shows you month by month exactly what happened, and it gives you the totals also. So the total for the year, this is 2019. The home used 7,057 kilowatt hours, generated 9,972. That's what came from the power plant. Well, this is what they drew from the grid, only 374 kilowatt hours. And overall, they exported about 3 megawatts.
Wow.
So if you multiply that number by about 4 miles per kilowatt that you get on the average EV, that's a little over 12,000 miles that that this building generated. That's for each unit, or for this particular unit. So microgrids, benefits and dividends, financial impact on the building scale, which I like to call a nanogrid. You have resilience, no loss of your food, your communication, your income if it's a business, lower operational costs, potentially zero energy bills. You can generate that revenue from excess energy export and actually create HOA dividends for your owners.
So considering all the, from a total cost of ownership perspective, you said they sold for 10 to 15% premium relative to the market at that time.
Well, it's hard to judge, but yeah.
Give or take.
Yeah.
So given the premium price for the unit buyers and this, basically 1 year of total cost of ownership data that we have, can you map that forward to when that evens out?
Yeah, I mean, we could do that. We didn't do that exercise, but we could map it out. It's a good idea. But what you don't factor into that is what's the value of the resilience that you get from the system, right? And we do have the methodology that I'm going to go over in a minute at the Clean Coalition that we developed called Value of Resilience that can kind of help you put a number to that, not precisely, but it's sort of a sliding scale because your house being resilient is different than a hospital being resilient, right? There's a much higher value to that resilience in a hospital than in your home. A hospital, the power goes out for an extended period, people die. Your house, the freezer thaws, so it's a different kind of value, but yeah. You can start to generate revenue from the ancillary services to the grid, as I talked about. You have free and renewable transportation energy, and all of that really equates to higher property values for your home and for your community. Moving out into the community microgrid, in a community microgrid you would have multiple renewable energy assets, community solar, wind, and hydro, potentially hydrogen from excess energy generation for long-range transport and even seasonal energy storage, fuel cells and CHP systems perhaps for backup, and also ideally net positive energy nanogrid buildings. So you have kind of layers of resilience within that community. There's again fewer single points of failure. You would have site-based and grid-scale energy storage potentially, ideally, and then also a community-based energy management system for sharing that community energy. And that's the policy work that good people like Allie are doing, and others in the room to help that become a reality. So,
what's the closest, sorry to interrupt, but how close are you to getting to, or have your team develop actual community microgrids?
It's like Chris said, all the technology's there. They're doing it in other places in the world. Japan has some really fine and functional community microgrids right now in operation. It's really mostly policy work that needs to be done now. And then also work on standardization, because as every community is different, so to try and standardize it, it's a complex engineering trick, but it can be done, something we could do. It's a moonshot, it's something we need to do. So community microgrid benefits, their scale. One thing that I like about microgrids is that they don't have to be, it's not a top-down solution. You can start small with a few systems, interconnect them, add to it as you go along. So it can kind of grow organically and then expand as the assets and the funds become available. They can connect to or island from the larger grid for resilience again, And ideally, we will eventually create an interconnected grid of microgrids with a lot of resilience, a lot of security, and that's the direction that we try to work at at the Clean Coalition, and myself as a private developer also. Isolated communities such as islands and those at the end of grid feeder lines are really those that are most vulnerable, like Chris said, and that's where we really need the most to start with. And also, those of us affected by the PSPS events, and I was affected by those. It really hits home. I think it's been sort of an eye-opener for a lot of communities in California, and that's why I think there's been a lot of work pushing forward microgrids, which is really great. 5 minutes? Okay. Well, I'm going to skip over this because I have something much more exciting that I want to tell you about. These are some next-gen projects that we're going to do. A larger, up to 50-unit building in the Richmond Bay area. We're going to do AC-DC hybrid systems that will include V2B and V2G integration. With a micro to macro mobility system, we're going to try to eliminate the need for private vehicle ownership altogether in this building, and maybe even not even allow it. It's near the Richmond SF Ferry and BART, so it's good for commuting, and it will be mobile energy microgrid enabled, and I'm going to go into that right now. I talked a little bit about V2B and V2G ready. This allows your energy storage capabilities to be expanded, could potentially quadruple the energy storage in Solex Alpha, for instance. It's another tool for grid balancing and ancillary assets. Adds to community resilience because your mobile energy storage can be a community generator, actually go out and provide power to the community. And it actually can extend your nanogrid into becoming a community microgrid without using utility wires at all. Because they can tell you how to use their wires, but they can't tell you where to go to call. So it will. This is the technology that's coming in from Canada that I'm helping introduce. It's a company called Osiaco. Product is called Decibel, and it is a solar inverter and bidirectional vehicle charger combined. It's a 21 kilowatt solar inverter, and it is capable of exporting 15 kilowatts of continuous power from the vehicle, which is the equivalent of 3 Tesla Powerwalls. So it's a really amazing system. It's got 2 ports per charger. One of them is bidirectional, and the other is a charging port only. It is the fastest residential EV level 2 charger in the world. It gives you 1 mile per minute while charging at home, and it does this through DC coupling and DC charging directly to your car. It's the most powerful solar inverter, not the most powerful, but it's pretty powerful. It helps you reduce your net zero home cost by combining these systems. You're actually saving quite a bit of money. The bidirectional flow allows your EV to act as a backup generator as well, and they have a really nice management platform they call Orchestrate. It's a really nice user experience that shows you what your system's doing. It can give you your monetization on the graph. It's also weather predictive, so it'll tell you to store more energy and not use it, actually. This is a dashboard that kind of shows you everything that's going on inside the house, what you're using, what each car has in it, what the battery, whether it's charging or discharging, what your solar is doing, if you're exporting or drawing from the grid, and also what's happening with your stationary storage system if you have one. And they've also found a way to gamify it and connect people and compete. So it's everything I want to do. It's really exciting. I can't wait to get my hands on it.
When will it be? When will it be?
It'll be available in March of this year. So they're going into production this month, and it'll be on the market in March. Is the projection.
Does it interconnect with the Tesla Powerwall?
Tesla is one company that doesn't want to play yet. Tesla likes to own the whole ecosystem of what they work with. But I'm going to actually introduce it to Chris as a Blue Planet, and they're looking for battery companies to interact with. But it's a wonderful user interface, and I think that's a big part of what makes it so user friendly, and everybody's going to want this when it comes out, in my opinion. Can I tell you more about this? I'm running out of time. It actually minimizes battery degradation through a pure DC battery charging system, so it's not converting. It reduces ripple effect and really helps reduce the degradation of the battery. They do have an agreement with Nissan already, and we're working with other manufacturers to get that in place. This is a cost comparison, sort of compared to other components that you would put together. Your solar and a solar inverter, battery charger, another battery charger over here, 2 chargers for your 2 vehicles, and a home energy management system. Total cost would be about $19,000 with an installation time of a full day at a minimum. Whereas this kind of replaces the need for all of that equipment. The equipment cost is about $6,500 and the installation time is about 90 minutes. It actually takes less time to install than a solar inverter. And it's actually in production. I mean, this is a working unit in one of the founders' homes. We've had it in testing up in Montreal for about a year now and performing as expected. So what this has the capability of doing is shifting electric vehicles from becoming a grid liability to a grid asset. There was just recently a study done by SoCal Edison, or for SoCal Edison, that showed that with a penetration of only 10% of the current vehicle market of bidirectional EVs, they could completely flatten the duck curve. So, once we get beyond 10%, this is a real solution for the grid, and it's exciting in that regard as well. So my idea is that a grid-optimal prosumer nanogrid community with bidirectional EVs can become aggregated renewable energy mobile assets, and you can actually develop a wireless community microgrid doing this. You can move energy around vehicles. You can use them as a virtual power plants to offset the need for peakers. The nanogrids can net meter for off-peak EV charging and load shift. You have ancillary grid services enabled. And all the more nanogrids and smaller systems you have, you reduce need you have for community scale systems. So again, you're saving costs of the overall system by componentizing it and breaking it down to smaller elements. First, you'd want to add some community scale renewable energy and storage, and then have nodes of connection at the grid to provide ancillary services to the larger grid as well. This was a slide on the value of resilience. Can you make these available to people later?
I was going to ask if you'll make them
sure.
available. I'll put them,
Yeah.
so in the email next week, I'll link them to that.
Yeah.
If you're on the newsletter. So otherwise I don't have your email.
So this is a link to what we've done for the value of resilience here, methodology down here. Basically, it breaks into 3 tiers: mission critical, life sustaining loads, priority loads that you want to maintain as long as possible, and then discretionary loads in tier 3. And it kind of helps you break it down into what your priority loads are, and then put a number to it. This is the link to the ECMR document, we call it, which is Electrification and Community Microgrid Ready. So if you want to just wire your home to be ready for these technologies, you can do this pretty simply using this document. The total cost to electrify, total wiring cost to electrify and be community microgrid ready is approximately $1,000. But you're actually saving a lot of cost because the cost of gas is much more than that, adding gas infrastructure into a building. There's a little slide on that. Savings from eliminating gas, this is from Redwood Energy, around $25,000. So the total cost to be ECMR ready is $1,000, you save $24,000. And then you can put that money towards your solar and storage system. So in closing, I just want to ask, what's better, wires or non-wire alternatives? Yeah. So these technologies here on the left have evolved and integrated into a greater whole, and now it's time. Actually, these have integrated into these have evolved and integrated, and now it's time for energy to do the same. So the integration of energy, built environment, transportation is at hand.
Questions, and I also have to take 1 or 2 questions, and then we'll break for networking, and then can do one-on-one.
Okay. Any other questions?
We took those around. What solar contractor did you use for the project on Mission Street?
We used a company called PAS Inc., Precision Air Services. They're an HVAC, electrician, solar, not roofing, but they're combined three. They're good. Greg?
Thank you for the tour before you sold the last unit.
Yeah.
Question, what's the customer satisfaction of the buyers? Are they functioning as an HOA? And how is the satisfaction based upon what you're interacting with them?
It's been extremely positive feedback. The quietness that was created by passive house construction, because of eliminating those thermal breaks, they're also acoustic breaks, right? And airtight means sound tight. Air quality's been phenomenal. The energy systems have been performing flawlessly. I got a text from one of the owners once, they were all excited. They said, power's out in the whole block and we didn't even know it. You know? So we got in the elevator and said it was on backup. So, yeah, so they've been really happy. It's good. I mean, that's good for a builder as well as a
Did you do an energy model for some or all of the units? And if so, have you had any chance to sort of compare expected energy usage versus?
Yes, we did, and it's right about on target. So it really worked out just as we expected. It was kind of rare, actually. So go ahead and play it.
Yeah, I was just going to ask about bidirectional charging on EVs, since there's a kind of a direct incentive against doing that because of the shortness of life of EV.
Right.
I was wondering how that fits into your...
That's important. So I mentioned briefly about the DC charging that minimizes battery degradation. The other thing about using your car battery to power your home, when you drive, that's the most energy intense thing you're going to do with your vehicle. You step on the gas, you're using 100 kilowatts output. When you power your house, it's a much, much lower rate of energy discharge. And if you keep it in that mid-range capacity of your vehicle battery, which is easy to do because the battery is so huge compared to what your home uses, there's really very minimal degradation in battery loss.
Just a follow-up, are the car manufacturers allowing bidirectional?
Some are. But once this is available and people can have it and they want it, I mean, think what it's going to do for EV sales. Now your car is your energy as well. You know, I think everybody's going to jump on board. Okay.
Any good sources for DC appliances? When I looked, a month ago, I looked for new appliances, and I was looking at DC, and I couldn't find any other than...
There's a few, yeah, I mean, check eMerge Alliance, that's a good group to check with, but reach out to me later and I'll share what I know.
Okay, great, thanks.
Real Goods Trading Company.
Oh, yeah, up in Hoffman? Yeah, okay. All right.
Thanks, everybody.
Thanks, John.